Hi everyone, we're back to Chapter 3, Lecture 2 of 3 lectures, and this is covering the uh, Matter and Energy in Chapter 3, Concepts in Critical Thinking, 7th edition by Charles Corwin. So we're going on to this particular section. We're going to talk about the elements. So I have this picture here of the elements, which I've found. This is hanging on the bulletin board in Lowell in the hallway on the 4th floor. But if you look at it, we have, so this would be helium. Here's helium. This would be hydrogen. You can't really see it in a container. And then we have the gases: neon, argon, krypton, xenon. We have different elements. Okay. So this is what they look like in their pure state. So elements, we're going to talk about elements, and we're going to talk about elements. That's what we're going to do in this section of the lecture. All right. So the first thing we're going to do is elements are the building blocks of matter. There are over 100 elements that occur in nature. 81 of them are stable. And 92, uranium, is the last element that's found free in nature. Everything after 92 is made in the laboratory. Then 10 elements account for more than 95% of the mass of the Earth's crust, water, and atmosphere. So there are the 10 elements that by mass. So you can see oxygen and silicon are really what most of the Earth is composed of by mass. All right, oxygen, and then silicon is sand. So there's a lot of, you think of all the oceans, so that's, and oxygen's in water. So that would be, you can get why you have a high percentage of oxygen. Hydrogen is, there's a lot of hydrogen, but it's so, the mass of it is so light that it's actually insignificant in its percentage. So these are the elements in the Earth's crust, water, and atmosphere. Then the elements in the human body. This is oxygen is the most common element in our body, in the Earth's crust, and in our body. Okay, in the Earth's crust. Silicon is the second most abundant element in the Earth. Carbon is the second most abundant one in our body. Okay, so here we have 60 in our body. It's 65% oxygen, carbon. Then you have hydrogen. That's, hydrogen and oxygen give you water. Carbon has to do with carbohydrates. If you have proteins, proteins have carbon and oxygen, have some nitrogen. So that would be in this 7%. That would be here in the 7%. All right. Then if you look at the Earth's crust, we have oxygen and silicon, calcium. That's pretty high. Iron, aluminum. Now again, this is by weight. Okay, so that makes a difference. Not necessarily the number of atoms. All right, and then they have other here is 9.2%. The names of the elements. How do we get these elements? Each element has a unique name. They have several ways they do them. One is from the Greek. Then you do Latin. Scandium is named after Scandinavium. Curium is named after Marie Curie. Nobelium after Alfred Nobel. Usually the naming of them, that's the naming of them. All right, let's see if the symbols. So each symbol is abbreviated, each element is abbreviated using a chemical symbol. The symbols are 1 or 2 letters long. All right, they're never more than 2 letters. Many of them are 1. And I gave you a periodic table that you can actually look at that while we're talking. I think that's a great periodic table to look at while we're discussing this. I think I'll get my periodic table. So one I gave you in lab the other day, periodic table of the elements. So if you look at that, you look at the symbols, you'll see they're 1 or 2 letters. Notice that they're always an uppercase. So the first one that you have is always an uppercase. So that's carbon is just C, cadmium is CD. All right, when you have a second one, it's lowercase. Usually, sometimes, like hydrogen's H, oxygen's O, nitrogen's N. All right, some of them are the first 2 letters, like calcium is Ca. Some of them the first and third letters. Some of them have Latin names. So there's all different things. Okay, here's Latin names: gold, Au, silver is Ag, and you just have to memorize these. I have a chart in here that you just need to know these. You need to know the correct spelling and name of the elements. It's the same as learning vocabulary. It's just really vocabulary. So zinc is here, Zn. Potassium is from a Latin word kalium. Gold is aurum. Silver is argentum. Copper is cuprum. I don't remember what mercury is. Iron is ferrum. Tin is stannous. I don't remember. And sodium is natrium. I can't remember what they're. It's a little bit complicated. So these are Latin. Why are they Latin? Because early on, Latin was the name that, that's what we use. We use Latin. So we're, that's how we name these elements. All right, so this is the table that you need to know these elements. All right, I don't know if I'll make it on the next test, but at some point in this course, I'll give a test on the element, a quiz on the elements, and you have to know all the elements and their correct name and their correct spelling. I think one of the ways to best learn it is to take index cards, and I would put all the elements that have just one letter on one set. Then I would put another one where they have the first and second letter of the name on another set, and then I do the first and third, and then I would do the ones that are special. That's how I would learn it. All right, so we'll have a test on that, and you need to know the correct spelling, boron, and the symbol for it. Notice these are all uppercases. All right, and then we have hydrogen is H, oxygen is O, phosphorus is P. So get all these ones that have just one symbol together, and learn those, and then learn the ones that are the first and second. Let's see, silicon, Si, selenium, Se, radium, Ra. These are the most common ones that you need to know. You need to have a working vocabulary of the elements, their names and symbols. So now when we look at elements on your periodic table that you have, that I gave you, there are three different types of elements. So if you look at the table, we have metals, nonmetals, and the third group are semimetals or metalloids. And semimetals have properties midway between those of metals and nonmetals, and they're located on that periodic table that I gave you on either side of the staircase on the right, where you see boron, aluminum, silicon, germanium, arsenic, that's antimony, tellurium, polonium, astatine. So they would be the metalloids that they're referring to in number 3 here. Okay, this is summaries of properties. Again, there's in the textbook, there's more of the written, the descriptive part. I again say I like charts. So here we have the general characteristics of metals and nonmetals. So here we have the property. This is a metal. This is a nonmetal. So physical state, all metals are in a solid state. Oh, well, that's not true. It's actually not true. Mercury is in the liquid state, and that's a metal. So that's not completely true. Gases can be solids, or nonmetals can be solids or gases. Now this next one, appearance, the metallic luster, that is really the most important way to identify a metal, is if they're shiny. Metals are shiny and nonmetals are dull. Or another one is pliability. Metals, you can bend them. Think of copper wire or aluminum foil. You can bend it. Another name is ductile, which means you can draw it out in strings. And then nonmetals are not that, so they're brittle. Conductivity, metals conduct heat and electricity. Think of putting a silver spoon into a hot cup of tea or coffee, and the spoon gets really hot. Nonmetals are non-conductors. Density is usually high. Nonmetals usually low. You know what density is. Melting point for metals is usually high. Nonmetals low. And chemical reactivity, metals react with nonmetals. Nonmetals can react with metals and nonmetals. So they said there are numerous exceptions to these general characteristics. For example, mercury and bromine are liquids. Magnesium metal has a low density, and gallium metal has a melting point below 30 degrees. All right, so there's just some general exceptions. So here I put this periodic table in so we could take a look at it. And if you look at it here, over here on the left, here's the staircase I was talking about. These are your metalloids here. They have properties of metals and nonmetals. Okay, they have semi-metals. Notice all the metals. See all the metals? Most of the elements are metals. The millions and millions and millions of compounds that exist on this planet are some combination of these elements. And here you have uranium down here, Anything, all these elements that are beyond uranium are all synthetically made. Uranium is the last metal that we can find in nature. So then we have nonmetals over here. Okay, and this again is a chart in your book that you can take a look at. You can actually take a look at it. Okay, here's gases. We have gases. Nitrogen, oxygen, fluorine, chlorine, neon. All these here are gases. This here is that they're radioactive. That's that they decay. Okay, that's a radioactive decay. All right. Let's see if there's anything else on here. Liquid at normal temperature, metallic, solid. This is a pretty cool chart. So you can take a look at that and look at the properties of, the elements. So the periodic table, which is what we were just looking at, is in each element is assigned a number to identify it. It's called the atomic number. The atomic number is always a whole number. All right? It's always a whole number, and it's in the top right corner of the box. So hydrogen's atomic number is 1. So if you look at the periodic table I gave you, hydrogen atomic number 1. Then you go over to the right, you'll see helium in the top is atomic number 2. Up to uranium, which is atomic number 92. The elements are arranged by atomic number going from left to right on the periodic table. Metals, nonmetals, and semimetals. Okay, metals, you just talked about that. Metals are on the left side, nonmetals are on the right side, and the semimetals are in between. So now in this chart, of course, it has the atomic number on the left side, the left box, all right? The periodic table I gave you has it in the right box. So if you say atomic number 92, there's only one element that has atomic number 92. You probably all know carbon. Carbon's atomic number 6, oxygen atomic number 8. You probably know those. You probably heard those before. Okay, this is the symbol. We call these symbols. And then we put the atomic number. Notice it's going from left to right. So we have hydrogen here, 1. Then we have helium. Then we go back to 3, 4, 5, 6, 7, 8, 9, 10. All right, so we have metals over here. Most of the elements are metallic, and they have very few non-metallic, but there's lots of things made from them. Carbon alone makes millions and millions and millions and millions of compounds. So even though there's a few, and then these elements here in this column here aren't very reactive, so it reduces them even more to a fewer number of nonmetals. Pretty amazing. All right, here's the physical states. So you can look at that. Most of them are solids. The two that are liquids are mercury and bromine. Then we have some gases. Now elements 104 and beyond continue to discover new heavier elements beyond the current periodic table. And UPAC is the international organization that assigns names to the elements. So if you think you made a new element, then you can say that you did, and then what you have to do is publish your procedure. And then scientists from around the world try to duplicate your procedure, see if they come up with a new element. And then by peer review, if you get enough people that can do it, then you are given credit for that particular element. And if you do that, then you can offer a name. And then UPAC would assign a name to the elements. And before that, the names using Latin prefixes for the numbers followed by the suffix IUM. So now, before you get the name, they're just using, they have particular Latin prefixes that they're using. But once you name it, then you'll actually get to name it whatever you want to name it. All right, so this is the unit on elements in the periodic table. And if you go to the Mastering Chemistry, there is assignment where you start. So this is all one homework assignment, but I thought a little too much for one thing. So if you go to the tutorial elements in the periodic table, and then you go to up to and including exercise 334, then you will complete all the assignment for this part of the material. All right, that's it, and then come back and we have our third lecture.